right?
Yes.
Okay. I'm going to start.
Today's class will be 1 hour.
Yeah. I don't know about it. Let me ask Nishka sir. Do you know about it? It's for 1 hour.
I actually have a maths class at 5:30. That's why.
Okay, then we will have for 1 hour. Okay.
Okay.
5:30. Okay. So do you have any doubt regarding this topic?
No.
Okay. So we are going another preparation now, another method of preparation of alkane, and here it is third from carboxylic acid. How we prepare alkane from carboxylic acid. First, I'm going to write, then I will explain it. Sodium salt of carboxylic, sodium salt of carboxylic acid sodium salt of carboxylic acids on heating with soda lime. With soda lime. Soda lime is basically mixture of NaOH, sodium hydroxide, and calcium oxide. Soda lime is mixture of NaOH and calcium oxide. Gives alkanes containing one carbon atom less than one carbon atom less than carboxylic acid, less than the carboxylic acid, and this reaction is known as or this process of elimination, we can say this process of elimination of carbon dioxide, that is carbon dioxide, write with me, carbon dioxide from carboxylic acid is called decarboxylation. Is called decarboxylation. What I want to say is that from carboxylic acid, I wrote here sodium salt of carboxylic acid. Concentrate here, Akifah.
Okay.
Do you know what is carboxylic acid? CH3COO.
Yes.
Carboxylic acid, right?
Yes.
Now you know that this is ethanoic acid, and if you will ionize it, you will get CH3O and COO minus plus H plus, right? In the same way, I can also write when we put this in a solution of sodium, then it will be like sodium, it will be like this. This is called sodium salt of carboxylic acid. Sodium salt carboxylic acid. Got it? Negative will attract a sodium Na positive, and it will form sodium salt of carboxylic acid, and reaction proceed. I'm going to show you. There is a reaction C double Na plus. This is sodium salt of carboxylic acid reacting with NaOH in the presence of Ca, the soda, and when we heat it will evolve CO2. This CO2 evolve, this part of CO2 will be evolved, and here CH3 and this H will combine. Am I audible?
Yes.
Now you see Na, this Na and Na combined together and will form Na2CO3. And this CH4, what according to the sentence, it says that one carbon atom less than the carboxylic acid. Carboxylic acid or carboxylic salt, you can see how many number of carbon is here. How many number of carbon is here? You can see one or two. Okay. So one of the carbon will be used in Na2CO3 and one carbon left, and with one carbon only CH4 is possible as alkane. So I write CH4. Please write it and I will give another example. It will be more clear.
Okay. Done.
Done. Did you write the reaction?
No.
Alkane of one carbon is called methane. Alkane of two carbon is called ethane. Alkane of three carbon is called propane. You know all this?
Yes.
Okay, just it and let me know.
Done.
And please try to solve this. Can you solve it? Okay.
The product is CH3 plus Na2CO3.
Very good. So what you just did, count the number here, number of carbon 3, but you have to less 1, so it will be 2, and 2 number of carbon 2 and form alkane, that will be ethane, and the formula will be CH3. Very good. Can I move to the next one?
Yes.
So moving to the next part. This was the first from carboxylic acid. This was the second, coal-based electrolytic method. This is also very easy. Coal-based electrolytic method. It basically double the product. And how it doubles the product. So if I'm going to write a theory about it, then I will explain it. Write with me. An aqueous solution of sodium or potassium salt of a carboxylic acid on electrolysis gives a containing even number of carbon, containing even number of carbon atom. So you can see what happens. CH3COO minus Na plus. This is sodium salt of carboxylic acid react with H2O. Am I audible, Akifah?
Yes. Yes. Sir.
And we do electrolysis here. We do electrolysis. It will evolve carbon dioxide. Just see, carbon dioxide, H2 and 2NaOH byproduct. It's all called byproduct. And here you can see how many carbon is present here. How many number of carbon present here? Two number of carbon.
Yeah.
So, and two number of carbon, CO2 is already released in the form of 2 CO2. And how many number of carbon is left? One. And it will be doubled because we have taken 2 moles. So everything will be doubled. 2 CO2 will be released and CH3 it will be doubled. First you have to release CO2 carbon dioxide, and then with the left number of with the number of carbon left, you have to do what you have to do is double. If we are going to have CH3 CH2 COO minus and Na plus, and here it is 2H2O, and you do electrolysis, what will be the product? First think about it. CO2 will be released, and how many left? 2, and double of 2 is 4, so the product is CH3 CH2 CH2 CH3.
Okay.
CH2 CH2 CH3 plus 2 CO2 plus H2 plus 2 NaOH. What you just said?
The screen was not visible.
Oh, the screen is not visible. Wait a minute.
It's visible.
Is it visible?
Yes,
Wait
now
a
it's
minute.
visible.
I'm going to CH3. Is it okay now?
Yes.
Thank you.
Done.
Done?
Yes.
Very good. Okay, move forward. Please do a course this is CH3 H2 CH2 COO minus Na plus my order. So we are doing electrolysis. Please write for Hydrocarbon is syllabus of hydrocarbon is completely all the syllabus, or are there any deleted syllabus?
Um, there are a few deleted topics
Like
in alkanes. One second.
deleted topics. Tell me the name of deleted topics.
Pyrolysis is deleted, and the reaction mechanism of halogenation.
Okay.
That's it.
There is from Alkane, right?
Yes.
Anything
What?
alkene, the deleted topics from alkene.
Nothing is deleted from that.
Okay, nothing is deleted. Please do this question and we will move to the next one. What is the IUPAC name of the product?
Which product?
Can you solve this question?
Are you sharing screen?
Wait a minute. Yes, I just shared the screen. Is the screen
Yes,
visible now?
Yes. The product will be butane.
Butane or hexane. What you have to do is CO2. 2 CO2 will be released. 2 CO2 will be released. Now 3 carbon is here and double of 3 is 6. So it will be hexane. 1, 2, 3, 4, 5. It will be hexane na? Akifah.
Yes.
Okay. Can we move to the next part?
Yes.
Now, come to the physical properties. Properties. Two types of properties are there. One is physical properties and another is chemical properties. So physical properties is all about generally melting point and boiling point. So melting point and boiling directly proportional to molecular weight, because molecular weight directly proportional to van der Waals force of attraction. If molecular weight will be larger, then that means van der Waals force of attraction will be larger and boiling point and melting point will be highest. So if you want to arrange this in increasing order of their boiling point, you can easily arrange it on the basis of their surface area or on the basis of their molecular weight. So boiling point will be in this order. Is this clear?
Yes.
Now, if you will have a given question like I'm going to give you, this is pentane, this is also pentane, this is also pentane. Arrange them in increased order of boiling point. Can you?
The one which has more surface area has higher boiling point.
Okay, which one has more surface area? The first, second, or third?
First.
So this will be the order of boiling point.
Yes.
That's right. Are you done with this?
Done.
Okay, for chemicals. So chemical properties, we will have different type of reaction with alkane. We will react different things from alkane. First is basically substitution reaction. Substitution. It's fluctuating today. Am I audible?
Your voice is lagging.
Uh, is your screen visible, Akifah?
Yes.
Okay. Am I audible clearly?
Yes.
Okay. In substitution reaction, we are going to study halogenation. So basically, what is halogenation? We are going to add halogen. So what happens? CH4 will be added into Cl2. Cl2 is added into CH4 in the presence of H nu, or we can also say sunlight. What happens is CH4 carbon has 4 bonds, so it will break one of its bond from hydrogen and it will be 3, and chlorine will go and substitute the position of hydrogen and it will be like this. Carbon always forms 4 bonds, so it will maintain its bond, like you can see. So when a bond is breaking, this will also break, and if one of it will go here and one will make bond from here, and it will be CH3Cl. If again you are going to react CH3Cl into plus Cl2 in the presence of H nu, it will be like again the carbon and hydrogen bond will break and it will be CH2. One of the hydrogen will go to chlorine, and chlorine bond will break and it will be Cl again. From earlier there was one Cl, and again one Cl will add and it will be CH2 Cl2, and here it will be HCl. Are you getting my point, Akifah?
Yes.
Okay, just write it.
Done.
Done. Can you do this? CH2 Cl2 plus Cl2 in the presence of H nu. Can you do this? Let me know the product. What will be the product?
CHCl3 plus HCl.
CHCl3 plus HCl. Now again do this, and after doing it, write all the possible products. Do this first, then again.
CCl4 plus HCl.
Very good. What is the name of this CCl4 IUPAC name?
I don't know.
You can say 1, 1, 1, 1 or tetrachloromethane. You don't need to represent 1, 1, 1, because it is understood that tetrachloromethane. What is the name of this? You can say 1, 1 will be understood that. Are you getting my point?
Yes.
This is dichloromethane. Okay.
Okay.
Moving to the next part, which is very important. Draw all possible product. Monochloro product.
CH3, CH2, CH2Cl plus HCl.
Very good. Any other product? So you can see, you just pick one of the chlorine and you put it here. I can also put it here, chlorine. I can attach the chlorine here as well as here, but this position and this position will be the same position, right?
Yes.
So all the possible product will be like two product. The one which you are calling HCl is byproduct. Okay, so concentrate on the main product. This and this product is possible basically. Apart from this two, there is no product in terms of alkane, haloalkane. So can you name this?
Which one?
The first one, 1-chloropropane. And what is the name of the second one?
2-chloropropane.
2-chloropropane. Okay. Write all the possible product of this. You have to attach Cl here, 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 everywhere. And at the same time, see which one of two is identical. So the identical one you don't have to write.
The first and last.
What?
The first and last will be identical.
And the second, this will also be identical. Identical will be recognized as we name it. What I'm going to do is going to put chlorine everywhere, like 1, 2, 3, 4, 5. First I'm going to put here chlorine. Second, 1, 2, 3, 4, 1, 2, 3, 4, 5. Chlorine I'm going to put it here, like I'm going to put it here. I'm going to put it here, and I am going to put it here as well. Now name it. 1-chloropentane, right?
Yes.
Name it 2-chloropentane.
Yes.
3-chloropentane. 1-chloropentane. The one which have same, the two which have same nomenclature are identical. This name, this is also 2-chloropentane, right?
Yes.
So you can see this and this both have similar name, that means they are identical. This and this have both similar name, that means they are identical, right? So it
Yes.
has three products only. The first product is this. The second product is 1 2 3 4 5 1 2 3 4 5. The second product is this, and the third product is this. Okay, so it has only three products. Okay, just write all this, then we'll move to the next chemical properties, which is combustion.
Done.
Good. So here it is, combustion. The second chemical property is combustion. Combustion, you know that burning of anything, that is due to oxygen. So whenever we are talking about the chemical properties of alkane, so they will react with oxygen. So you can see whenever there is oxygen, there is a combustion of hydrocarbon, that is hydrogen or carbon. It will give CO2 plus H2 as well as heat. That's why combustion is an exothermic reaction. It is an exothermic reaction. That means delta H is negative. Change in enthalpy is negative. So you can easily balance. Can you balance it?
Your voice is lagging.
Now it is balanced. Okay. Am I audible now? Akifah,
Yes.
am I audible now? Am I audible clearly?
Yes.
So what I want to say is that combustion is an exothermic reaction. That means delta H negative. Whenever there is combustion, that means reaction with oxygen of hydrocarbon, whether it is alkane, alkene, or alkene, it will always give carbon dioxide plus water plus heat. So you can easily balance it. So if I am going to give you a general formula, which is very important, if there is CnH2n plus 2, this is for basically alkane. So here it will be, this is general formula for balancing. 3n plus 1 divided by 2O2 will give NCO2 plus N plus 1 H2O. If I'm going to give you a question like C5H12 plus O2 will give CO2 plus H2O, can you balance this equation with the help of this?
Yes.
Okay, just balance it. Just write all this.
C5H12 plus 8O2 gives 5CO2 plus 6H2O.
Very good. So you wrote all this. Can we move to the next part?
Yes.
Always remember, whenever there is incomplete combustion, that means CH4 plus O2. This is also in gaseous state. This is also in gaseous state. And there is incomplete combustion. So carbon dioxide won't form. Here, carbon monoxide will form. And it will be like this. Not carbon monoxide. Wait a minute. It will be carbon coke solid. Just right. Incomplete combustion.
Done.
Very good. Now, right topic, controlled oxidation. In organic chemistry, reaction also depends on reagent or the condition. If the reagent will change, the product will also change. Control oxidation, you can see 2 mole of CH4 will react with O2 in the presence of Cu copper at 523 Kelvin and 100 atm pressure, and it will oxidize to alcohol. It will oxidize to alcohol. Methane is converted into methanol. If I'm going to change the situation, 1 mole of CH4 react with 1 mole of O2 in the presence of molybdenum trioxide, and we will heat it, then methanol will form. That means aldehyde. HCHO plus H2. You can see is methanol and this is methanol. Also 2CH3CH3. If you are going to, that means 2 moles of ethane will react with 3 moles of oxygen in the presence of peroxide CH3COO whole twice Mn, manganese peroxide, and if you heat it, then carboxylic acid will form. CH3, this is ethanoic acid along with 2H2. And if you are to wait a minute, Akifah. If you are going to take tertiary carbon CH3 whole thrice CH, and you took a best oxidizing agent KMN4, that is oxidation. You are oxidizing it, that is oxidation. Then CH3 whole thrice COH will form, that means alcohol. 2-methyl, we can name it. You see, again 2-ol. You can write all these equations. These are all controlled oxidation according to situation or condition. We can have our different requirement fulfilled. Like if we need methanol in our chemical industries, we can have by this process.
Done.
Done. Come to the part isomerizes. What part? Am I audible?
Yes.
Isomerizes. Isomerism, you know that isomerism, what does isomerism means? That means same chemical structure. Isomerization is also same. If we are going to take CH3, CH2, 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 CH3, and we are going to take anhydride AlCl3 in the presence of HCl, then you just have to isomerize it. Just write the isomers of it. According to me, it can be like this: CH2, CH2, CH2. You can see six number of carbon here. It is 1 2 3 4 5 6. Okay, and you can also write like CH3, CH2, and whatever you want to, but it should be same 3 2. So it will be CH3. This is isomerization. You can see 2-methyl pentane or 3-methyl pentane.
Done.
Yeah, very good. Now move to the next part, which is aromatization. What is aromatization? Basically, it is converted to, it will be converted into aromatic compound. So if we are going to take CH3, CH2, 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 2, 4, 5, 6, CH3. Going to take chromic anhydride Cr2O3 or V2O5 or molybdenum trioxide at 773 Kelvin, that means 500 degrees centigrade, and 10 to 20 atmosphere. This is hexane. This hexane will be converted into benzene. You can see. Done.
Yes.
Mm. Now reacts with steam. Reaction with steam. So you can say CH4 reacts with steam, that is in the form of H2O, in the presence of nickel, and the temperature is high, like 100 Kelvin. So it forms carbon monoxide plus 3H2. Whenever methane reacts with the steam, this will form.
Done.
Do some questions. I'm going to give you some questions regarding write the IUPAC of the following. Can you write it?
Mm. First one is 1,3 butane.
1 comma.
3 butane.
So you said 1, 2, 3, 4. But 1 comma 3 diene. It will be diene now.
Yes.
Very good.
What will be the second one?
So this is OH alcohol, right? And
Yes.
do you know that when OH is directly attached, which is directly attached on benzene, it is called phenol. Do you know or not?
Yes.
Do you know it? Very good. This is basically phenol. Phenol is a common name, and now it is treated as IUPAC as well. And IUPAC name is also benzenol. So we give preference to functional group 1, 2. So the name will be 2-methyl phenol, you can say, or benzenol, you can say. Can you name the third?
Deck 2 comma
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will be
deck
4-ethyl first, then deck, then 1 comma 5 comma 8 triene. Will it be or not?
yes.
Okay. So Akifah going to start in the next class. Make sure we should have 1.5 hours classes for 1.5 hours.
Okay.
So we will cover the topic. Okay.
Okay.
Okay. Thank you so much for today.
Okay.